So for this example, we have a rational function, r of x equals x minus 1 over x squared minus 4. We are going to analyze the graph, which means follow all the steps on the front of the page, all 6 steps, and use all that information to do a detailed graph here. So I'm going to go through each step, and hopefully I can fit them all in here, and then use all that info to graph. So the first one is simplify, which means we're going to factor the top and factor the bottom and see if anything else will cancel. So we have x minus 1 on top. On the bottom we have x plus 2, x minus 2. If we were to factor the bottom, nothing will cancel. So we are all simplified and ready to go. Step 2 is to find the intercepts, and I'll find the y-intercept first. In order to find the y-intercept, I plug in 0 for x. So it'd be r of 0 equals 0 minus 1. And you can plug it into your simplified version or like the factored version or the original. I'm going to do the original. 0 squared minus 4. So it looks like it's going to be negative 1 over negative 4, which is 1/4. That's my y-intercept. I'm going to write it as 0, 1/4. My x-intercept I get by setting 0, or plugging in 0 for y. So it'd be 0 equals x minus 1 over x plus 2, x minus 2. I use the simplified version. Here, whenever you're looking for an x-intercept and you set it equal to 0, the first step would be to multiply both sides by the denominator. That gets that to cancel, and it stays 0 on this side. So what you end up with is just 0 equals the numerator, because the denominator is going to multiply out and go away. So here I have 0 equals x minus 1, add 1 to both sides, and I get 1 as my x-intercept. I'm going to write that as 1, 0. I'm actually going to graph those as I get them. So there's my 1/4, and there's my 1. Step 3 is find the vertical asymptotes. Vertical asymptotes is setting the bottom equal to 0. So if I set the bottom equal to 0, I can solve algebraically. I'll add 4 to both sides and square root. So I have 2 vertical asymptotes. One's at 2 and one's at negative 2. I'm going to put those in by drawing dotted lines at 2 and at negative 2. All right, step 4, horizontal asymptotes. There are 3 cases. Because my power is bigger on the bottom than it is on the top, it is the case where the horizontal asymptote is 0. So I'll put that in. And remember, horizontal asymptotes are not really so much for the middle, they're only more for the outer parts of the graph. So I do have a dot on my horizontal asymptote here, but that's okay. You just can't hit it when you get out further away from the origin. Step 5 is plot additional points. What I need for my additional points is I need to have a point in each zone. So I need to have a point over here, I need to have a point in here, and I need to have a point over here. So I will have to, I'm going to do my table because I like having like a sideways t-table. And so I'm going to need to have one in this zone, like a negative 3. And then I also need to have more points around my intercept. So like I need to have a negative 1, and then I've got that, and I've got that. So we should be good there. And then I'll pick one in this zone, 3. And then I'll see, maybe I want more later. If I need more detail. So what you do is you plug negative 3 in for x, so it'd be r of negative 3 equals negative 3 minus 1. Negative 3 squared is 9, so 9 minus 4, so it looks like it would be negative 4 over 5. So that's an ordered pair over negative 3, down 4/5. There's a point there. Now I'll plug in negative 1. Looks like I'm going to get negative 2 over negative 3, so I'm going to get 2/3. So that would be back 1 up 2/3. And then 3. Plug in 3. Looks like I get 2/5. So the dotted lines are supposed to really structure your graph. You cannot cross a dotted line. So like here, my graph is going to kind of snuggle up to the dotted lines on each side, and same thing over here. If you're unsure about those shapes, you can just plug in more x values and try to get more ordered pairs to have more accuracy. Here, I have 3 that I can connect, and I'm not allowed to loop back over because it's a function, and then I'd fail the vertical line test here. So my only option is to go by that vertical asymptote here. If I went down here, I would create another x-intercept, and I know there's no more than just that. So I cannot go down, I have to end up going up. So there is what my graph would look like.